Hello class, I'm going to walk through a hypothesis test with you. So a light bulb manufacturer guarantees that the mean life of their light bulbs is at least 750 hours. This is our claim, that this manufacturer is guaranteeing that the mean life of their light bulbs is at least 750 hours. A random sample of 36 light bulbs has a mean life of 745 hours with a standard deviation of 60 hours. Is there enough evidence to reject the claim for the manufacturer using 5% significance? So the first thing to do when we are going to do one of these hypothesis tests is to write our null hypothesis and our alternative hypothesis. Represented here is H sub 0, which is our null hypothesis, and H sub A, which is our alternative hypothesis. The important thing to remember is that that equal sign always has to be with the null hypothesis. In this example, the claim is at least 750 hours. That equates to greater than or equal to 750. So our null hypothesis contains mean greater than or equal to 750, and in this example, the null hypothesis is our claim. It doesn't have to be that way. The alternative hypothesis could represent the claim, but because the equal sign is with the claim, that is under the null hypothesis. So because this is greater than or equal to, the opposite of that is less than 750, meaning every possibility has been accounted for. There's no other possibility. You're either equal to 750, which is represented here, or greater than 750, which is greater than here, or less than 750, which is represented in the alternative. The next thing that we should do is draw a picture representing this claim. And then to do that, we look at our alternative hypothesis and we look for the symbol either being less than or greater than or not equal to. When the symbol is less than, which it is, our p-value area is to the left. If it's greater than, the area that we would have shaded would be to the right. And if it's not equal to, that would be two-tailed, meaning we would have an area to the right shaded and an area to the left with an area in the middle. The next thing we need to do is calculate our test statistic. On the second slide in the PowerPoint, there are three formulas there that allow you to calculate a test statistic. And they coordinate, if you will, to us creating confidence intervals. There's a z-value, a t-value, and a value when you have a proportion. And just like with a confidence interval and the margin of error, the z-score is used when you have values greater than or equal to 30, your sample size greater than or equal to 30. If you have a small sample size, then you would be looking at a t-value. And then with the confidence, with a proportion, again, it's a z-score, but you would be using a different calculation. So in this example, we're not doing a proportion, we are doing a mean, and we have a sample of 36 light bulbs, which is greater than 30, so we can calculate a z-score. And the formula given is this. So let's go ahead and calculate that. Give me 1 minute. Okay. So we have our sample mean, which in this case is 745 hours. And we are going to subtract from that the claimed mean, the population mean, which is 750. And we're going to divide all of that by the standard deviation, which is 60. And we're going to divide that by the square root of n. N is always our sample size, which is 36, and the square root of 36 is 6. So that gives us, on the numerator, 745 minus 750 is minus 5, divided by, and then we have 60 divided by 6 in the denominator, which is 10, and that is equal to a negative 0.5. So this is our z-score, but we are going to be looking to compare p-values. P-values are just our probabilities with our alpha, which is, in this case, our alpha is going to be 0.05. So we need to find the p-value or the probability associated with negative 0.5. So I'm going to come over here to the table. Here's negative 0.5. We need 0 to be in that tenths place. So here's the 0. Here's negative 0.5. So our p-value is 0.3085. So we have P3085, and we're going to compare that to our significance level, which is 5%, which is 0.05. And we can see that 0.3085 is greater than 0.05. And then this also was on the PowerPoint slides. This is telling you how you interpret that information. If the p-value is greater than alpha, which it is, do not reject the null hypothesis. So the null hypothesis was that the mean is greater than or equal to 750. We cannot reject the null hypothesis. The data is not strong enough to support the alternative hypothesis, which is the mean is less than 750. So notice the way that these interpretations are worded. It does not say that we are rubber stamping the null hypothesis or that this is absolutely true. It is just saying that we do not have enough information to reject it. So we do not reject it because our data does not support rejecting the null hypothesis. So in this example, we cannot say that the mean is less than 750, and we cannot reject this claim, which is the mean is greater than or equal to 750. Okay, I hope that helps, and reach out if you have any questions or concerns.